In this video, we're going to talk about the comparison test, and this comparison test is the last resort test that we will use. It's the toughest one to use, but we do need to know it. So let's take a look at what it says. It says, let A of k and B of k be series with non-negative terms, and B of k is always going to be larger than A of k. Well, we're going to know two things about this. If the bigger series, B of k, converges, then the smaller series, A of k, also converges. We know that if the smaller series, A of k, diverges, then the bigger series, B of k, also diverges. Be very, very careful about what this does not say. When the bigger series diverges, we don't know anything. When the smaller series converges, we don't know anything. So all we know is that when the bigger series converges, the smaller series also converges. When the smaller series diverges, then the bigger series also diverges. That can get pretty sticky. Let's try an example. So we have a series 1 over 2 plus 3 to the n, and we're trying to figure out whether this converges or diverges. So we're going to compare it with the series from 1 to infinity of 1 over 3 to the n. Because generally speaking, we can drop an addition of 2 plus to anything. Now, we learned earlier with some tricks that we're allowed to rewrite this as 1/3 to the n. That makes this a geometric series, and since the absolute value of r is less than 1, this thing is going to converge. So if we look back at our rules, since we think it's going to converge, we want to prove that that's the bigger series, because if the bigger series converges, then the smaller series also converges. So now let's do our comparison. We are comparing 1 over 2 plus 3 to the n with 1 over 3 to the n. Now, notice that the left side, 1 over 2 plus 3 to the n, as n goes to infinity, will always be smaller than 1 over 3 to the n. So since 1 over 3 to the n is the bigger series, and since it converges, then we know that our original also converges. So you have to be very careful with this one. Let's try another one. So now we're going to look at 1 over 2 plus root n. Well, so let's see if we can compare that with 1 over root n. So 1 over root n is really the same as 1 over n to the 1/2 power, which is the divergent p-series. So we think that this thing might diverge if we go back to our original rules. If we think it's going to diverge, then we need to prove that it's the smaller series to use the comparison test. So let's do a little comparing. So I've got 1 over 2 plus root n, and then I've got 1 over root n. Well, unfortunately for us, this thing is always going to be either greater than or equal to what we're trying to compare to, and that doesn't really help us very much because we think that one diverges. So we're kind of stuck with the comparison test, but if we look a little further, we could try to compare it with 1 over n to see if that also works, and that one diverges. So let's take a look at that one. If we compare 1 over n with 1 over 2 plus root n, what we know is that the one we're comparing to will eventually be smaller if n is greater than or equal to 4. So we know eventually when n is greater than or equal to 4, this thing will diverge. Again, this is a very tricky test. We try not to use it except in last resort cases.